In this video, we're going to look at some of the anti-tank and anti-personnel mines that were used in World War II. There were a multitude of types available, but we are only going to show and talk about those we have access to. To start, we are going to look at the mines used by Germany. Perhaps because of the amount of territory they needed to protect, they produced a large variety of types. Here we can see an aluminium carrier for two Telemine 35s, carried by pioneer troops. This is the Telemine 35. Tele is the German word for plate. This mine was introduced in 1935 and its body is made of aluminium. This was to reduce the weight when carried. It is fitted with the TMI Z35 igniter, which is made of brass. It has a small screw slot to arm or disarm it. It incorporates two booby trap pockets into which can be fitted various igniters to prevent the mine from being removed. This feature was included in all subsequent models. This mine was expensive to manufacture and more importantly was using aluminium, a material needed for the aircraft production, and so it was superseded by this, the Telemine 35 Stahl, or steel. This was manufactured from pressed steel. It used the same igniter, however it had the ability to accept the new type of igniters that were under development. The pressure setting on this mine could be adjusted by means of the tool shown here. The TMI 35 could also be adjusted. This is the UB35 training version of the Telemine 35. It is a very heavy steel construction. It was laid in the same way as the conventional mine, but upon detonation it emitted smoke. It can be taken apart and refilled with new smoke charges. It was a useful learning tool for both the pioneer troops and the tank crews, and it gave them the experience of what would happen when a mine was set off. Here is the next step in the evolution of the Telemine. Introduced in 1942, the Telemine 42. This is its steel transit case. As you can see, it has a smaller pressure plate, the area that sets them off the mine, rather than the complete top as on the previous model. This was to address several operational issues. Again made of steel, but this mine takes the new TMI Z42 igniter, which was cheaper to produce. We now look at the final development of the Telemine series, the Telemine 43 Pilz or Mushroom. Here is its crude wooden carrying frame. Of steel manufacture, it does not incorporate a spring-loaded pressure plate as on the previous models, but relies on a hollow pressure plate crushing under the weight of the vehicle. It also incorporates the new TMI Z43 igniter. In the previous designs, once the mine had been checked for anti-handling device, it could be safely defused by removing the cap and taking out the igniter. In fact, sometimes they were relayed by the Allies. When you insert the TMI Z43, the act of screwing down the cap shears a small safety pin. Any attempt to unscrew the cap and remove the igniter results in detonation. Here we can see two igniters side by side. The red stripe identifies the TMI Z43 and you can see the shear pin. This is a Holtz Mine 42, a wood mine. Based on those that they had encountered in the Soviet Union, it was cheap to make. To waterproof it, it was sealed with bitumen. It used the ZZ42 igniter as used in the shoe mine, which we will look at later. When the red band is showing on the raised pressure block, the mine is armed. This is the Regal Mine 43, which is a bar mine. This was based on an Italian design. It could be fitted with a variety of igniters and operated by shearing wire passed through the top and bottom halves. This mine proved to be extremely dangerous, both to those laying it and those trying to remove it. The safest course of action was to blow it up in situ. We will now look at some of the anti-personnel mines. This wooden carrier contains 3 Schutzen or protection or S mines, which are anti-personnel mines. To the Allies they were now known as the bouncing Betties and were lethal. The SMI-35, its abbreviated designation, consists of 2 main parts, the outer cylindrical housing and the inner body, to which the igniter for tripping the mine is attached. The assembly is buried, leaving just the top of the igniter protruding. On the top plate there are 3 screws for the delay detonator pockets, a filler plug screw and a central screw thread used to attach the igniter to a tube that runs to the bottom of the body. Below the top plate, the inner body consists of an inner and outer sleeve. The inner sleeve contains the main explosive charge, and between this and the outer sleeve are placed several hundred steel balls The steel balls were only used early in the war. Later, cut metal fragments and even small pieces of barbed wire were used. At the very bottom, between the inner body and the outer housing, is a black powder launching charge. The mine operates as follows. When the igniter is tripped, it fires, sending a flame down the central tube to the launching charge and the delay detonators. This projects the mine into the air about 3 feet, 90 centimetres, at which point the 3 delay detonators operate. The main charge explodes outwards, deploying the balls or metal fragments. In 1944, the SMI-44, a simplified version, was introduced, easily identified by the offset igniter thread, and apart from the filler plug screw, there is only a single centrally mounted detonator pocket. The operation of the mine is similar to the SMI-35. When the igniter is tripped, it initiates the launching charge, but instead of the 3 delay detonators, there is a thin steel wire attached to the bottom of the outer housing and to a detonator in the centre of the inner body. When the inner body reaches about 3 foot 90 centimetres, the now taut cable operates the detonator, exploding the inner housing outwards. A variety of igniters could be used to set off the mine, either by pressure, tripwire and very occasionally electrically. The SMI-44 also introduced a new multi-function pressure/pull igniter to simplify deployment. Although detectable with mine detecting equipment, this was often not available, and so troops would have to resort to using a bayonet to probe for the mine, as there was very little visible above ground. As they could be booby-trapped with tripwires, they were extremely dangerous, and they accounted for a lot of Allied infantry casualties in World War II. Here we see the Schutzen Mine 42, commonly known as the Shoe Mine. This was constructed from wood. It contains a block of explosive into which is screwed a ZZ-42 igniter, the same as that used in the Holtz mine. When the hinge lid is depressed by someone stepping on it, the pin is forced from the igniter, which allows the spring-loaded plunger to fire the charge. The Glass Mine 43 is another example of a mine that could not be easily detected by a mine detector, which relies on a large metal component to work. Glass mines were ideal for use on the Atlantic Wall, as they could be sealed against water ingress. 2 types of igniter were used in this mine: the Hebelzunder, literally lever fuse, also known as the boar heads fuse because of its shape, or the Buck chemical igniter, which contained a small glass vial of acid which is crushed and reacts with another chemical to detonate the mine. The moulded top plate sits on a very thin sheet of glass. The ribs in the top plate allow soil or sand to be held in place to aid concealment. Stepping on this, smash the thin glass sheet and detonates the block of explosives within. 2 examples of the stock mine, stick mine in English, another improvised device made from concrete but with metal fragments embedded. These were often placed in pairs with a tripwire between them. Cornfields in Normandy being one example where they were extremely difficult to detect. These small mines, of which there were many types, were known as picric pots because they used picric acid as the basis of their explosive. The larger of the 2 was designated the A200 and the smaller the A150. Both tended to be fitted with chemical buck igniter, although many other types of fuses will fit. Here we see a selection of igniters for use with German mines. This wooden box contained the igniters and other bits for use with the S mines. Although I said in the introduction we would only discuss those mines we had access to, I would like to mention the Topf mine, pot mine, as it has a number of unique features. These were made of wood pulp and sawdust and pitch and used glass components. They were undetectable by normal detectors, and this was a problem for the Germans should they need to lift the minefield. The solution was to sprinkle tarn sand, camouflage sand, on top of the mine. It was slightly radioactive and could be detected by certain German mine detectors which incorporated a crude Geiger counter. I thought we'd mention this as it's quite a unique type of mine. This is a Russian TM-35 anti-tank mine. Introduced in 1935, it saw extensive use during the Winter War with Finland. Finland captured large stocks and reused them against the Russians. Made of steel, the igniter goes in a small hinged side pocket. We will now look at mines used by British and Commonwealth forces. This is an EP Mark II anti-tank mine. In use at the start of World War II, these are much smaller than their German equivalent. They operated on spring pressure. Once this was overcome, a plunger crushed a chemical ampule, causing the mine to detonate. It was advised not to try and disarm or lift them and reuse them. The safest course of action was demolition in situ. This is a Mark V General Service anti-tank mine. By 1942, when these were introduced, it was obvious that as German armour became larger, so the earlier mines were too small. This mine was once again operated by overcoming spring pressure, but it had a conventional percussion igniter. Many thousands were laid in the Western Desert. This is the anti-personnel shrapnel mine Mark II. It was the British equivalent of the German S-mine. This mine also launched into the air before exploding, but when we look at it dismantled, for those familiar with a grenade, you can see the large lever which would fly off once the inner part leaves the outer casing. This would then start a fuse burning and the mine would explode about 3 to 4 feet above the ground. Whilst this object is referred to as a Hawkins grenade, it is in fact a lightweight mine developed for airborne troops, used singly or strung together to form a line. They work by the top plate crushing and setting off the igniters. They were carried by Allied airborne troops on D-Day, the Americans often strapping them to their leg. Here we'll look at some of the mines used by the US. This is the M1 mine. It was the US standard anti-tank mine at the start of the war. Of note is the fact that it is much smaller than its German counterparts. It used a conventional percussion igniter and a spider-type pressure plate. This is the M1A1, essentially the same as the M1 but with improvements. It's identifiable by the later design of spider pressure plate. Both types incorporate a safety spring fork which is removed when the mine is laid. This is the M6 heavy mine, introduced to deal with the larger German tank, seen with its carrying frame. The mine is armed by rotating a lever in the centre. This particular mine is the M6A2 variant, which uses a mechanical rather than a chemical fuse. Here we see the M2 family of anti-personnel mines. They are bounding mines like the German S-mine, meaning that they are launched into the air. In the case of the M2 mine, it uses a modified 60mm mortar round head. The earlier version has a large round base. This would be the M2 or M2A1 variants. Later versions with a small base, M2A3, again with many sub-variants. Most of the designation changes were to do with simplifications of manufacturing processes. I hope you've enjoyed looking at some of the variants of mines that were produced during World War II. There were many more. Please hit the subscription button if you'd like to see more videos like this.